Okay, I'm gonna do a really quick video on domain of logarithms, and it doesn't really matter if you've got a base 10, okay, base 7, base E. Okay, it doesn't matter really what goes on there. So don't be freaked out if you see something under there. Okay, but the first thing I want to do is I just want to graph. Let's just go ahead and graph the natural logarithm. Okay, so it's gonna kind of look like this. That's not a really good graph, but it'll work. But I want you to just take a look at. Maybe even if you have a graphing calculator, you can go ahead and punch it in there. And what you're going to end up, it's going to graph something that looks kind of like this. It's going to, it's going to intersect at 1 right there. I'm going to maybe make that a little stronger. And it's just going to it's going to do this number, okay? Now, even if you just punch in, like, if you punch in just on a regular calculator, natural log 0, it's probably gonna give you an error, or it's gonna say it's undefined, and it's actually, I think the math dudes actually say it is undefined. But look at the graph here. It actually, as we get closer and closer to x equals 0, as x gets closer and closer to 0, the natural log function starts to go towards negative infinity. So, you could kind of hypothetically say, that natural log of 0 is, goes to infinity, but since it's not a real number, and I'm not even going to I wanted to make this video short and sweet, so I'm not going to go into anything to do with infinity, because it's, pretty complicated. But see, you can see what's going on, okay? So the thing I really want to get at is just by looking at this graph, is at the end of the day, okay, when everything's all said and done, this, whatever you're taking the log of, okay, it better be worth more than 0, okay? Because this function's not even defined out here in the negative region. It's got to be greater than 0, and we just showed it can't be 0, because then we get into the infinity zone. So this is pretty much the main point, okay? Let's just concentrate on keeping our log above 0. Okay, so let's go ahead, and I'm just going to make one up. Let's say we have f of x equals the natural log of x plus 3. Okay, well, let's go ahead and graph that. Picture's worth 1,000 words. Okay, so here's 1, 2, 3. Here's 1, 2, 3. Let's see here. We basically took this function right here, natural log of x, and we just backed it up 3 units, didn't we? Okay, that's just remember from transposing functions. When you add it, you back it up, that away. And if this was a subtraction problem, we'd move it over to the right. So we just basically took natural log x, we just backed it up 3 units. So it did intersect at x equals 1. 1, 2, 3. Looks like it's going to go ahead and intersect right there. Okay, so I'm gonna go ahead and note that, and then let's remember natural log of x has to be greater than 0. So, well, this doesn't have to be worth more than 0, but x, whatever we take the log of, has to be greater than 0. So let's set x plus 3 greater than 0, okay? So it looks like x has to be greater than negative 3, okay? If x is negative 2.99, we still have a little minute number in here, you know, 0.01, that we can take the log of, and that'll actually give us the answer. Okay, so we back this up 3 units, and it actually kind of makes sense, because now here's our asymptote back here, and if I go and graph this, like we said, it's going to intersect right here. See how, maybe I'll zoom out in a little bit. Now you can see how that happened. We just kind of backed it up a little bit, and now here's our new graph. And it makes sense, you know, if this thing's worth 3, okay, if x is worth -3, then we end up with natural log of 0, right? Which approaches -infinity, and we can't do that. So that's kind of where that goes. So let's see here. How about we do one more? Never hurts. You know, looks like I got enough time. And let's interest ourselves in f of x equals natural log of x minus 5. Okay? Well, x minus 5 needs to be greater than 0, doesn't it? So I'm going to go ahead. X has to be greater than 5, right? Because if x is 5, then we end up taking the natural log of 0 again, and that's a big no-no. So let's go ahead and graph this thing. Basically, we just took our regular, here is 1. I'm going to call that 1 right there. And we shift this to over 5 units. So 1, 2, 3, 4, 5. And it looks like our new asymptote is right there, and this graph is gonna kind of crash into my deal, and that's 2, 3, 4, and there's 5. So yeah, it makes sense. You know, if x is equal to 5, then yeah, I run into my vertical asymptote, and we all I don't know, we all burst into flames. You know, I don't know. But that's basically, you know, in a nutshell. You know, that's all you need to remember is whatever you're taking the log of, you've got to ensure that it's greater than 0. So I hope that worked, and I hope you got a little better understanding of what's going on as far as finding the domain of logs and where they're defined at, and right there. Oh, and let me just ask you a real quick question. What is the range here of the log? Okay? What's the range of a logarithm? Well, it looks like this thing will eventually, this will taper off, but well, that's a good question. I think the range is infinite, probably -infinity. We know it approaches -infinity, but does it approach positive infinity? I'd say it does. Just looking at it, maybe I don't know. Maybe if you guys are curious, let me know and I'll do a video on that. So I'll see you in the next video. Okay.